Welcome to Get Your FRQ On. This question is from 2002. It is question 2, and it is calculator active. In the question stem, we have two functions representing the rate at which people enter or leave an amusement park. E of t gives us the rate at which people enter the park. L of t gives us the rate at which people are leaving the park. You can check those specific functions by actually looking up the question yourself. The link to the actual free response questions is provided in the description below. Part A asks us to the nearest whole number how many people entered the park by 5 p.m. Well, the total number of people who enter the park by 5 p.m. would just be the definite integral of the rate function, E of t, from 9 a.m. to 5 p.m., which in military time would be 1,700 hours, or t equals 17. So we're just going to take the definite integral of our E of t function from 9 to 17. This is a calculator active question, so feel free to use your calculator to do this unless you're really feeling up to the task and want to do it analytically. But the actual integral turns out to be a little bit more than 6,004.270 to be exact. But it does say round to the nearest whole number, so by 5 p.m., approximately 6,004 people have entered the park. In Part B, we're given that people who enter the park before 5 p.m. are charged $15 for entry. People who enter the park after 5 p.m. are charged $11 for entry. How much money did the amusement park make in this day? So here's what happens. We have one function that tells us the rate at which people enter the park, and that function is good for the entire day. So what changes is the cost that people pay to enter the park at different times. So what we need to do here is we need to make sure that everybody who enters the park before 5 p.m. pays $15. Everybody who enters after 5 p.m. pays $11. And to do that, we can take our definite integrals and just multiply them by the appropriate costs. So the number of dollars made in that day is going to be 15 times the integral from 9 to 17 of our E of t dt function, plus 11 times the integral from 17 to 23 of our E of t dt, which turns out to be $104,048 and change. So to the nearest dollar, the park makes about $104,048 that day. In Part C, we are asked to find h prime of 17 and explain its meaning. Given that h of t is the integral from 9 to t of e of x minus L of x dx, and given the information that h of 17 is 3,725, and then to explain the meaning of both. All right, so h prime of 17, by the fundamental theorem of calculus, is just going to be e of 17 minus L of 17, which it's a calculator active problem. You can use your calculator for this. Turns out to be negative 380.281. And then the meaning here would be, h of 17 just tells us the total number of people in the park at 1,700 hours or 5 p.m. And then h prime of 17 equals negative 380 simply means that this number is decreasing at about 380 people per hour, specifically at t equals 17 or 5 p.m. For what value of t between 9 and 23 is the number of people in the park maximum? All right, so either this is going to occur at an endpoint, or it's going to occur somewhere between the two intervals, the two endpoints, where h prime of t is equal to 0. So h of 9 would just be the integral from 9 to 9 of e of x minus L of x dx. Well, that should just be 0, which would make sense. The instant the park opens, there should not be any customers in there. H of 23 is going to be the integral from 9 to 23 of e of x minus L of x dx, which is like 1.014 apparently. However, it could occur somewhere in the middle where h prime of t is equal to 0. If h prime of t is equal to 0, that means e of t and L of t are equivalent at that time. and that happens when t is about 15.795. So if we evaluate our h function at 15.795, we have the definite integral from 9 to 15.795 of e of x minus L of x dx, which again, it's a calculator active question. Feel free to use your calculator to answer it and find this integral. 3,950.680, which is clearly bigger than 0 and 1. So the number of people in the park is maximized when t is equal to 15.795 hours.